Thank you everyone for coming, and good afternoon. Welcome to the session on streaming meets governance. So in this session, we'll be covering how you can expose your streaming data in Kafka topics and as Delta or other open table formats, and making them available to Unity Catalog and use it within your analytics services. So let's start with a quick introduction about ourselves. Victoria.
Okay. Hi, everyone. I'm Victoria. I'm a member of product staff here at Databricks. That basically means that I'm a product manager. And before Databricks, I was actually at Tabular. I was a PM there, and before that, I was an engineering manager at Shopify for data ingestion. So data ingestion is like a space that I specialize in and have spent most of my professional career.
Great. And my name is Kasun Indrasiri. I'm a senior product manager at Confluent, working on Confluent Tableflow. And before that, I was part of Azure Event Hub's team at Microsoft. All right, so let's get started with a quick overview of today's agenda. So we'll kick things off with an overview of the current state of the data lakehouse architecture. And then we'll dive into the challenges that you have in, especially when you're feeding these streaming data in Kafka to your data lakes or data warehouses. And that's where we're gonna look at how Confluent Tableflow, along with Delta tables and Unity Catalog, make it easier for you to expose all your streaming data for your analytics state. And finally, we'll wrap it up with a end-to-end demo of using Confluent Tableflow with Unity Catalog and use Databricks to perform analytics on your streaming data. All right.
Yeah, so we'll start by just talking about a little bit of what your data estate actually is. So we're all here at a Databricks conference, and Databricks is really a data intelligence platform. And what that means is that on one platform, we have all your data governed with a single pane of glass and unified. So we have all your data for all your data sources accessible from a single place. And with that, we're able to tune your AI to your business to create business intelligence. So how is this made possible? This is done through Unity Catalog. Unity Catalog is really the glue that makes the data intelligence platform run. It does this by having all the knowledge of your data in a central place, and it's able to govern all that data. Like I said, it's that single pane of glass for you to do your data and AI governance. And with Unity Catalog, we're able to power multiple pillars of the data intelligence platform, including your artificial intelligence workloads on Mosaic AI, data warehousing, Lakeflow to do all your ETL and transformations, as well as your business intelligence, your AI and BI. So traditionally, your data estate, this analytical estate, has been fragmented. There's so many different parts of this. We can solve it with components like Unity Catalog. There's governance, there's orchestration, there's your data lake, there's streaming in terms of like Kafka that we're going to talk about today, and data warehousing. And it's a complex nightmare to manage all of this. So what Databricks came up with, this is several, like going back a few years ago, is this data lakehouse architecture. And the idea behind this data lakehouse architecture is that we have different layers focusing on different parts of the stack. So at the very, very bottom of this diagram, we have your structured, semi-structured, unstructured data sets sitting in object storage. So think your Parquet files, your CSV files. Then on top of that, we have modern lakehouse formats like Iceberg and Delta. Now, several of those assets, whether they're unstructured data sets or your Delta tables, these can make up tables and AI models, files, functions. All of these can now be represented as an asset within Unity Catalog. And then Unity Catalog is the thing that is able to govern all of this. So then by having everything governed by Unity Catalog, it can give access and permissions, govern those permissions and access to a variety of engines. It is your access point. Engines being Fabric, it could be like Trino, open source Spark, it could be like Databricks, Spark, DBR, and this is what's able to enable you to do like streaming analytics, BI, data science, and machine learning. But where is the data coming from? So at the very, very bottom, like all of this sounds super, super great, but something needs to populate the bottom, this data coming into the lakehouse. So let's look beyond the lakehouse. What happens before?
Yeah. So you probably have heard the saying that your AI or analytics is as good as the data that you feed into it, right? So therefore, data coming into your lakehouse is super critical. Now, if you look at the data landscape of pretty much any organization, you can find data residing in two main states: operational state and the analytical state. Operational state is where you run your day-to-day business operations, right? So this can be your data coming from your website as clickstream data, or this can be data coming from your operational database in the form of a CDC changelog, or it can even be events generated from your financial transactions. So the key idea here is you need to store this operational data in your organization. Now, if you look at the technology landscape of operational data, Apache Kafka is the sort of the de facto standard that you can capture, store, and organize operational data. Now, if we take a look at the analytical space, this is the place that you perform various business analytics to generate insights from your various data sources, which also includes operational data. Now, in the analytical space, we are seeing the convergence of all these different table formats, right? So all are converging to use open table formats such as Delta Lake or Apache Iceberg. And with that, we can bring some of the key features that were previously missing in this, some of the legacy lake houses and warehouses. So things such as ACID transaction, using expressive SQL, schema evolution, time traveling, all those things are brought into the data lakehouse space by these open table formats. Now, the challenge that we have is how you can connect your operational data, right? Operational data with analytical state. Now, as Vicky mentioned, the data coming into your lakehouses from these all these operational systems. Now, if you take a closer look at the ways that you can connect operational data and analytical data, you have to build pretty much custom data pipelines to do this, right? You basically have a data pipeline written to consume data from your streaming source, which is Kafka in this case, and then take care of all the data transformation. That also includes maintenance of the tables that you are creating in your analytical space. Now, if you take a closer look at these use cases, they pretty much follow a common pattern. So you have your data stored in your Kafka clusters, and then you often ended up using something like a sink connector to dump raw data directly into your object storage. So this can be your S3 bucket or any other object storage. Now, after dumping data into your object storage, you need to basically convert this into these open table formats by performing various transformation and data pre-processing tasks. So this includes converting incoming Kafka raw records into Parquet or Parquet and Delta Lake or Iceberg metadata formats. And also you have to do schematization, syncing these tables to the catalog services that you are using. And once we have done that, you need to also maintain these tables continuously, right? You need to perform compaction, garbage collection, and all that. Now, after doing all those things, you can have bronze quality data by, like, you basically improve the quality and the structure of the data. And beyond that, also you can incorporate certain business-specific logics, filtering, deduplication, CDC materialization, so that you finally have silver or gold quality tables. Now, all these red boxes in this diagram is the toil of data pre-processing, right? So, because you need to perform analytics on streaming data, but you need to go through this toil. Now, assume that you can get rid of most of the toil of data pre-processing by simply exposing your Kafka data streams or Kafka topics as tables to your data lakehouse. So that is exactly what Confluent Tableflow is designed for. With Confluent Tableflow, you can, so it's a managed service offered as part of Confluent Cloud. So with Confluent Tableflow, you can expose your Kafka topics or data streams as Apache Iceberg or Delta Lake tables. And these tables can be materialized to your own storage bucket, right? So within a few clicks, you expose this topic as a table, and Tableflow will take care of performing all the, pretty much most of the toil of data preprocessing that we have seen in the previous diagram. Now here you can see we perform automatic performance of type mapping, conversion. So Kafka records are converted into Parquet and corresponding metadata formats. And we also schematize data based on the schema associated with your event or topic. So we are tapping into data that schema data available in the Confluent schema registry and use that to generate the target table schema. And then also we perform CDC materialization and also syncing data to external catalog services such as Unity Catalog. These tables are also actively managed by Confluent Tableflow, which means since this is a continuously written change log or event log, we have to keep on maintaining this table by performing compaction, garbage collection, and all that, right? So we perform table maintenance too. So therefore, these tables are exposed as sort of read-only external tables to your downstream analytics systems. So from any compatible compute engine, now you can tap into this data without having to go through the toil of data preprocessing. Now, I'm sure most of you are interested in knowing how we have built things under the hood. Because you may be wondering whether this is a fancy Kafka sync connector or not, right? So now, as I said, this is a fully managed service offered as part of Confluent Cloud. Now, if you look at the architecture of Confluent Cloud, we are using the Cora storage engine and Cora cloud native Kafka engine in Confluent Cloud. So as part of this storage engine architecture, we are using two-tier storage, where we have a local storage to keep all your most recent and frequently accessed data. Then we tier that to a separate cloud storage, which is based on S3 or any other object storage. Now, when you enable Tableflow in one of your topics in Confluent Cloud, what it does is it first fetches all the metadata from your Kafka topic and a schema from your schema registry. So this is how you generate the corresponding metadata of the table. And then we start reading data directly from the cloud object storage in the form of segments, right? So we are not writing another Kafka consumer application to read data, but we directly read data from the object storage. So this is very efficient, especially for very high volume workloads, as well as this put very less overhead on your Kafka cluster, right? This is not another consumer. And there can be situations that we may have to directly read data from Kafka consumer API as well, because in order to guarantee certain data freshness requirement, we may read data, but for the most parts, as long as you have sufficient volume available in the topic, we are reading data from the object storage. All right, so now with Tableflow, you can expose all your data streams available in Confluent Cloud directly to Databricks because we automatically publish these tables as Delta Lake tables and publish these tables directly to Unity Catalog so that you can pretty much use all the Databricks analytics services and generate insights from your data and feed all the AI models that you have. And so in the future, we are also working on adding the reverse of this also supported, which means you can expose your tables available in analytical state and expose them as topics to your Kafka consumers or to your operational application. So that is currently, it's the North Star goal that we have. Now I'll let Vicky to go through some of the key things that we can do with Databricks.
Yeah, so that was great. So now we understand where Tableflow fits in the stack. So now with Tableflow, we're able to have more of our operational data as part of our data intelligence platform. So that's making that data available to Unity Catalog, having this unified single pane of glass for accessing our data and governing that data. So I just wanted to highlight like a couple use cases of like, okay, now that I have Tableflow, what does this actually enable? So one thing I want to highlight is the clickstream use case. So at your business, you may have this use case where you have all these edge applications. This can be mobile phone, like web browser. You're capturing user interactions on a site or app, and these are being sent as messages to a Kafka topic. Now, with Tableflow enabled, we're able to actually query that data immediately in your data lake, in Databricks, so you can build real-time A/B test dashboards of that clickstream data. For change data capture, so we talked a little bit about that. Now that data is being fed, that's traditionally fed to the Kafka topic, and then you normally have to ingest and replicate that into Databricks. Now, with Tableflow enabled, that data is directly available to query. There's no ingestion pipeline to manage. And then for recommendations, this is more of like an ML use case. Maybe you're a customer, you have a product that's making some sort of AI recommendation. You want to log that recommendation. Typically, you may be sending these events to a Kafka topic and then building some sort of ML application using that data to bootstrap maybe a new model. Instead of reading all that data off of the Kafka topics also have retention, so it may not even have all the data. Now you can have this infinite retention with the Delta table with Tableflow enabled. And I'm happy to do Q&A more about that use case afterwards. So now that we understand some of the use cases, let's build a thing.
Sure. All right, so let me first explain the demo use case. So for this one, we selected a real-world stock market data set, which is collected pretty much like every few minutes. So it's an intraday market data. And now we are feeding that as a event stream or data stream to a Kafka topic. And then we use Tableflow to expose that as a Delta table in my own storage bucket. And then automatically publish that into Unity Catalog and then perform all the various data analytics capabilities on top of Databricks. So let me start playing the video. So here I have a Kafka topic created in my Confluent Cloud Kafka cluster. So what we are going to do next is we are going to feed my stock market data feed into this Kafka topic. So for that, I have a separate Kafka application that simply feed this data set into my Kafka topic. So I'm feeding the data stream. And now I should be able to see that available in my Kafka topic in Confluent Cloud. Now, as I said in my at the beginning, so there's a schema associated with this topic as well. So this arrow schema will be used to create the target Delta Lake table in this case. All right, now we have data available and we have the schema available. Now let's try to enable Tableflow and expose this as a Delta table. So for that, you can simply click on Enable Tableflow. Now you get the option of selecting the destination table format, right? So you can select Iceberg, Delta, or even both table formats. Now in the case of both table format, we are still sharing the same data files across both tables on top of two different metadata layers. So we are not duplicating data. Now in this case, I'm selecting Delta Lake tables. And then you can configure your storage bucket, right? So we are going to store all my Delta tables in my own storage bucket. Now, in the case of S3, in AWS, we are using AWS Assume roles to enable access from Confluent Cloud to your storage bucket. So I have already configured a construct called provider integration in Confluent Cloud, which configures all the AWS Assume role-based access. And I have given required bucket access IAM policy permissions to this role. And then I can provide my bucket name. Then you just have to review the configuration and launch Tableflow. So under the covers, it will start a separate materializer job and all the other data maintenance job, which are not directly visible to you. So now the status of the topic should now turn into from pending state to Tableflow syncing state. So it will take few minutes, few seconds. All right, now it is in Tableflow syncing state. And now also you can obtain the actual table location storage URL from the monitoring tab. You can just copy the URL and just navigate to the S3 bucket to see whether the table data and metadata is stored properly. All right, so this is my S3 bucket, and I'm navigating to my table location. So here you can see my Delta data files available in Parquet format. And then you have the Delta log also available. So far what we have done was we just expose a Kafka topic as a Delta table, but we haven't done any integration with Unity Catalog or Databricks yet. Now, the next step is to configure a catalog integration. Before that, this table will be used as an external table from Databricks. So therefore, you need to first create an external location which points to my S3 bucket. Now I have already created an external location in Databricks which points to my S3 bucket. All right, so now I'm going to use one of these catalog services. So I'm going to use this catalog and sync my table to this Unity catalog. Now, the catalog configuration or catalog integration is done at the Kafka cluster level, right? So you cannot really, like, individual topic cannot be directly synced to a Unity catalog, but it is currently implemented at the cluster level, which means all the topics that are under that cluster will be automatically published to the Unity catalog that you are configuring here. Now, you can, here you can add a catalog integration. So there are multiple options that you can select from. Since we are using Delta tables, we are selecting Databricks Unity, and then provide your catalog name. And this is where you configure your catalog workspace ID and client ID and the secret of the service principal associated with the which has access to the catalog as well as the external location. And then finally, you have to provide the catalog name here. Okay, so I'm using this catalog, and then I can navigate to the next step. So now you can review the configuration and launch a Unity catalog integration as well. Now it is in pending state. Within few seconds, it's now it's connected. So that means I should be able to see these tables available under my catalog. All right, now here I have a new schema created, and there are two tables that are created under my catalog. So the schema name is determined based on the Kafka cluster ID of the Confluent Kafka cluster, and here you can see stock real-time feed topic that we have just enabled Tableflow, and also there's another topic which I already had Delta enabled. Now, your data stream is available as a Delta table for Databricks, and now you can build your analytics pipeline from there.
Okay, so now I'm going to show you a little bit of like what happens next. So we have this table available. I'm going to look for it in Unity Catalog. There it is. And the next thing I want to do is like, let's just query some of the sample data so I understand what this table actually looks like and what is actually in here. So I'm going to run this query just to get some sample data, and let's have a look. I have a timestamp. I have a bunch of columns. that's like the ticker data that we were talking about before that's being pushed to Kafka. And what's sort of interesting as we scroll all the way to the end, that we actually have some Kafka-specific metadata here. So in the table, we're able to see the topic, we're able to see the partition, and even the offset of that message. So you could use this information for building pipelines that depend on ordering. So there's that information. Yeah, so we have all this Kafka data there. Okay. Yeah. Okay. So now what we want to do now that we understand our table is to build a pipeline. So I actually already created a pipeline that is going to transform some of this data. And I'm just going to show you what it's doing. So the first thing I'm going to do is actually create a data source. So here I created this view that's just going to take a date field or timestamp field cast as a date. I'm going to do some aggregation of the data based on date. And I'm going to select a few different tickers that I'm going to do this aggregation on. So I'm going to use like SPY and Apple and a couple of other tickers. And I'm going to produce this view that I'm then able to query. So now I'm going to write this pipeline that's going to transform some of the data. And what my transformation pipeline is going to do is figure out the daily high, the daily low, the open close values for my data for each of those ticker values that I'm interested in. And then we're going to build a dashboard. So with that pipeline running, we're able to have dashboards that are able to view the data from our transformations. And now with Tableflow, because the data is being pushed and made available to the Delta table continuously, this dashboard will actually be updated as that data is coming in. So we're able to run this pipeline in continuous mode, and this data will be constantly being updated. So now we've built this whole end-to-end pipeline. We have the data that's coming in through Kafka. We've enabled Tableflow. We built a pipeline, and now we're able to query it and build dashboards on top of that data. So that's everything that we have for today. We want to do a Q&A session, but before then, here's, you can do continued learning and blah, 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 but there's also a survey. This is the most important thing. Please go on the app and fill out a survey of our presentation. And what we would love to do now is, if you have any questions for us, come down to the pit here in the front, and we're happy to talk more about Tableflow and Unity Catalog and the Databricks integration with Confluent. Thanks, everyone.